Hello everyone, this is Aditya and today we will do some practice problems for end sem examination for mathematics. And note in this we will start from sequence series and not from the Rolle's theorem because I have already covered Rolle's theorem and the first two chapters already in my previous videos. So you all can watch that. I will send the link for that. Okay. So now let's start with from the sequence series and without wasting time we will directly move on to the questions. Right? Okay. So please do like, share, subscribe my channel and now let's dive into the video. Okay. So let's start with the question number one. Okay. See, I won't tell any concept. I will tell the concepts over here, but I won't discuss whole theory over here because it will be the waste of time because I have already covered them in my previous video. So you all can watch that. Okay. So I am directly starting with the questions. Okay. And note that I am not well, so please don't comment me if I make any mistake. Okay. Please see if I make any mistake. Please comment that I made the mistake. I will try to correct it, or maybe I will make a video on the correction of that. Okay. Okay, so now let's start. Let's see the question number one. We have to check the convergence of n is equal to 1 to infinity of 1 upon root n plus root n plus 1, right? We have to check the convergence of this. So how do we do this? Well, in this we apply the p-test. Okay, how does the p-test go? You all know. For example, if we have a series n to the power p as n goes from 1 to infinity, this is convergent if p is greater than 1 and is divergent equal to 1, right? This is the case, you all know. Okay. So notice that in this how we will assume the p. We assume such a p so that the limit, when we take the limit as n tends towards infinity of fx by gx is equal to lambda, it should be a finite value, right? So from that we conclude that if gx is converging, then gx will also converge. I mean, if gx is converging, then fx will also converge. If fx diverges, then gx diverges, like that. You all remember from my video of sequence series, right? Okay. So we have to choose such a function gx so that we get a lambda that is a finite value. So basically we choose of the power this is n to the power 0 by root n, right? So this is equal to g of x, which is equal to root n to the power 1 half, right? Okay. So we have got our gx, right? Okay. So now let's substitute it. What we get? We get limit n tends towards infinity of f of n by g at n, and it is equal to the limit as n tends towards infinity of let me write it over here so that it is clear. Okay. Let me keep the duster. Yeah. Now let's see. We get the limit as n tends towards infinity. What was the expression? It was 1 upon root n plus root n plus 1 divided by gx. Gx was 1 upon root n, right? Okay. Many people ask me that how I wrote root n. So like it's very basic, but still many people get confused because we don't write a 2 over here. So it is equal to n to the power half, right? Don't forget it, okay? So just bring that term in the numerator as n tends towards infinity of root n by root n plus 1, right? You get this, okay? Okay, so what? Well, you notice that as n is tending towards infinity, n plus 1 is almost equal to n only, right? Because we know infinity plus 1 is almost equal to, we assume it equal to be infinity. Obviously, this is wrong. I mean, I can't directly write infinity. I should be using the limiting case, but it's okay. I have to explain, so that's why I'm using it. That is why I can write it like this. Limit n tends towards infinity of root n by root n plus root n, which is equal to 1 by 2, which is a finite value. Okay. So notice that if I would have taken gx as suppose 1 upon n or 1 upon n square, what would be the case? It would be n square by root n plus 1, right? If I would have assumed gx as n square, not a root of n. Okay. So in this case, it would be diverging. You will solve the limit, you will get infinity as the answer, right? So that is why we have to choose very wisely a function g of x such that the limit becomes a finite value so that we can conclude anything, right? That is why. So we got a finite value 1 half, okay? Which means if gx is converging, then fx will also converge. But notice that this term, this is equal to, I mean, g of x was 1 upon n. So in this case, p was less than 1. Since p was less than 1, so g of x is diverging, so this also diverges. Okay, the question which was written 1 upon n to the that thing, that will also diverge. Okay, so now let's move on to the next question. Okay, sorry. Let's see another question. The question states this one, second one, question number 2. Summation n is going from 1 to infinity of log of n by n to the power 3 by 2, and this is whole square. So how do we evaluate such problems? Okay, so in this we will use integral test. You remember what is integral test? If this is your fx, f of n, summation n is going from 1 to infinity. What is f of n? It is log to the log n whole square by n to the power 3 by 2, right? So you will integrate 1 to infinity of fx dx. And notice that if it would have started from 2, then you will take the integral from 2, right? Okay. So basically you solve this, you get 1 to infinity of log of x by x to the power 3 by 2 dx, right? You will get this expression. Okay, so let's solve this and let's see what we get. And notice that if this will be converging, then the summation will be converging, and if this diverges, then the summation will also diverge, right? The summation is basically, integration is basically a summation of very small elements, right? That is why. Okay, so let's see, let me erase this. Now starting with the integral, let's see what we get. Integral 1 to infinity of log of x by x to the power 3 by 2 dx, right? So basically assume log of x equal to t, so you get x is equal to e to the power t, and we get dt is equal to dx by x, right? We get this. Okay, and notice that when x is tending towards 1, then t is going towards 0, since log of 1 is 0, and x tends towards infinity, t is going towards infinity, right? Since log of infinity is infinity. Okay, right? I hope that you are understanding it. Okay, if there's any doubt, you all can ask me anytime. Okay, so let's move on to the topic. Okay, so we get integral 0 to infinity of t square by, what we will get, from here we get dx by x. So it will be written as, notice that we can, first of all, let's see this integral. It was 1 to infinity of log of x by root x into dx by root into dx by dx, right? We got this. Okay, now change the limit 0 to infinity of what is log x. Log x is equal to t by, what is, it is equal to this quantity, x is equal to this, so you get root of e to the power t, right, into dt, since dx by x is equal to dt, right? Okay, so you get 0 to infinity of t, I guess it will be t only. Yeah, it will be, sorry, log x whole square, so it will be t square, right? T square e to the negative t by 2 dt, right? And I hope so that many must have understood that this is a gamma function. It is form of gamma function. We have to convert it. So let's put t by 2 equal to y, right? So we get dy is equal to dt. So 2 dy is equal to dt, right? Now let's substitute. There will no need to change the limit, since as t is going towards 0, y is 0, and when t goes to infinity, it is equal to infinity, right? So we get 0 to infinity of the quantity. What is t? T is equal to y. So 2y whole square e to the power negative y dy, right? Dy, and it is equal to dt is equal to 2. So we get 2 another, right? So we get like 8 times integral 0 to infinity y square e to the power negative y dy, and this is equal to 8 times the gamma of 3, which is equal to 8 times 2 factor, which is equal to 16. I hope so the method is clear. Maybe my calculation may be wrong at any point. I agree to it. Maybe it is wrong. I don't know. But the method will be this, right? And you got a converging value of this integral. Since you got the converging value, so it means the summation which was given from 1 to infinity of log of x whole square by n to the power 3 by 2, it is also converging, right? So I hope you understood this problem. Okay. Now let's see another problem. There's a topic which is there, application of integrals. So in that we we are told to find the path length and all. That is a part of JEE syllabus, so I'm not discussing it because it will take lots of time. If I get any time, I will try to make 3 4 question video on it separately by tomorrow evening. Else you all can do it on your own. Okay. So now let's see another question and let's see what is it given. This question, yeah, this one. This is a series 1 plus 1 plus alpha by 1 plus beta plus 1 plus alpha plus 2 alpha by 1 plus beta plus 2 beta and so on and so forth. So we have to evaluate this limit. How do we evaluate it? Let's see. Solution. So let's write its general term. We get like we get a of suppose u of n is equal to 1 plus alpha plus 2 alpha and so on and so forth till n minus 1 alpha upon 1 plus beta plus 2 beta and so on and so forth till n minus 1 beta. How do I how do I understood that this will be the expression? Because when you substitute 1 you get 1, this thing. When you substitute 2 you get this. Okay, and I read the pattern that it is going from 1 alpha and then 2 alpha, right? Which means it is going like this is third term, so you got 2. When it will be fourth term, you will get 3. That is why it is that n minus 1, right? Okay. So you get this, and then oh, I'm sorry, I think I wrote the question wrong. Yeah, I wrote it wrong. 1 minute. Sorry. This is a question. Sorry, I'm really sorry for that. 1 plus 2 alpha by 1 plus beta into 1 plus 2 beta. 1 plus alpha, 1 plus beta, 1 plus 2 alpha into 1 plus 3 alpha by 1 plus beta into 1, this is beta, 1 plus beta, 1 plus 2 beta, 1 plus 3 beta, and so on and so forth. Like, I'm really sorry for that. I was maybe thinking something else. That's why. So now let's see this one. So again, you make a general pattern. It will be like this: 1 plus alpha into 1 plus 2 alpha, and so on and so forth. Still, that is the same thing. N minus 1 times alpha by 1 plus beta into 1 plus 2 beta, so on and so forth. 1 plus n minus 1 beta. You get this thing? Okay? Is it okay? So how do we even check this expression? It looks so scary at first, but it's not. See, use that D'Alembert's test in this. How you evaluate, you will understand that it will become very simple when we use that. What is un plus 1? Un plus 1 will be equal to 1 plus alpha and this thing plus n minus 1 into alpha into 1 plus n alpha, right? You get this upon 1 plus alpha, 1 plus beta, so on and so forth till 1 plus n minus 1 into beta into 1 plus n beta, right? You get this thing? Okay? Okay, is it okay? Yeah. So now let's evaluate further how what we get. And to a great surprise you will understand that you got something interesting. How? Let's see. Well, un plus 1 is equal to, notice that this term is your un. I hope you understood, right? Is un times 1 plus n beta by 1 plus n alpha, right? You get this thing? Is it okay? Yeah. So let me erase this thing also and then we will see another. Okay. So you get un plus 1 by un is equal to 1 plus n beta by 1 plus n alpha, right? And now you use the D'Alembert's test, limit as n tends towards infinity, un plus 1 by un is equal to 1 plus n beta. I should put the limit. Limit n tends towards infinity of 1 plus n beta by 1 plus alpha n, right? Means n alpha, right? Whatever. 1 plus n alpha, right? Many a times it is taught like this un by un plus 1, but that is like it may be confusing, so that is why I use the consecutive term first. So un plus 1 by un, okay? You get limit n tends towards infinity of 1 by n plus beta plus 1 by n plus alpha. You substitute infinity, you get beta by alpha, right? Okay, so this thing limit n tends towards infinity of un plus 1 by un, it will converge for it will be greater than 1, it will converge, it will diverge, sorry, it diverges, and for less than 1 it will be converging. Is it okay? Why is it so? But it is because you know that since this is the next term and this is the previous term, so when you take the ratio, if the next term is increasing, it is greater than the previous one, then it's obvious that it will be diverging. But if it is less than 1, means if the previous term is greater than the next term, which means it is a decreasing series, so there are chances that it may converge, right? So we get this. Okay, so we get for converging condition beta by alpha must be less than 1. So beta must be greater than alpha for the case of convergence, right? Is it okay? Yeah. And I hope I did not make any mistake. Yeah, I did make one. It was 1 plus n alpha and it was n beta, right? So again it was alpha and it was beta and it was alpha and it was alpha and this was beta and this was beta. And now it's fine. It will be alpha by beta. So it is equal to alpha by beta. So you just change the inequality. So beta must be greater than alpha for the given quotient to be convergent. Okay, right. I'm sorry for that. I'm sorry, I'm not well. That's okay. So let's see next problem. I hope you all are enjoying the video and please do like, share, subscribe my channel. So now let's start. Okay. So let's see another type of problem which we can encounter. Well, we discussed this one and this one. I think we should discuss a problem related to the Cauchy root theorem. I hope you all know the Cauchy root theorem. Let's see. Okay, let's see the question. What it states? It states the summation as n goes from 1 to infinity of the quantity n plus 1 of x to the power n upon n to the power n plus 1. Right? Is it okay? Yeah. N to the power n plus 1. Right? This is the question. Yeah. So how do we evaluate this? You get un is equal to n plus 1 into x whole raised to the power n upon n to the power n plus 1, right? You get this thing, okay? So what does Cauchy root test tell? It tells that nth root of un is equal to, as n tends towards limit n tends towards infinity is equal to lambda, it will be converging for lambda, it will converging for lambda less than 1 and it will diverging for lambda greater than 1, right? I hope you understood. I know you all know, right? So we'll apply same thing over here. Okay, let's see. Let me write this thing over here. Un is equal to n plus 1 into x to the power n by n raised to the power n plus 1 as it is. Okay, you have written it. So now let's test it by using Cauchy root test. Let's see. Okay, so we get like limit as n tends towards infinity of un to the power 1 by n, right? I hope so. I should like write it like this. Okay. Okay. So you write this limit as n tends towards infinity of n plus 1 x whole raised to the power n upon n plus 1. It is 1 by n, right? Okay. You get this thing, right? So when you evaluate it, you get limit n tends towards infinity of the quantity. You get n plus 1 into x upon n plus 1 by n, right? You get this thing, okay? Is it fine? Yeah. So notice that it is again infinity plus 1. N is infinity, n is tending towards infinity, so infinity plus something very very small, that is 1. It is obviously equal to n only itself, right? So you can make this equal to n for simplicity, okay? Upon n to the power, you can write n plus 1 by n as equal to 1 as equal to n by n plus 1 by n is equal to 1 plus 1 by n. I'm doing the simplest calculation so that no one faces any problem. Okay, that is why. Okay, I hope you understand. Right. Okay. Sorry. So we get 1 plus 1 by n, right? Now you can simply bring it down. You get limit n tends towards infinity of x by n to the power 1 by n. And notice that I have already solved this limit in my sequence series lecture. You can watch that, right? I won't be able to solve right now because we have very less time. So that's why. So this is equal to x. Now this was your lambda. So lambda for greater than for less than 1 this converges, and for lambda greater than 1 this will diverge. So it means if x is less than 1 then this series converges, right? Okay, that's the thing. Now let's see one more problem. These questions are based on your PYQs and some of the reference books which you all use, and probably some of the notes or the PDFs which are getting circulated. So from that, I picked some nice questions which may be asked. I am not sure they will be asked. I'm not God, so that's why. Maybe they may be asked, they may not. But it's like I'm trying to build a concept for you all, right? That's the thing. Okay, so let's see one more question. We are given a question as summation n goes from 3 to infinity of the quantity root of 2n square minus 5n plus 1 upon this is plus 1 upon 4n cube minus 7n square plus 2, right? This is the thing which you are given. Okay, so in this again you will use the p test. Why? Because you see a simple algebraic terms, right? Okay. So what basically will be the value of p? You will take like root of the highest power of this upon the highest power of this. You get n by n cube. 1 upon n square is equal to g of n, right? So we know that g of n is converging since p is greater than 2, right? We know this. But now we have to check the limit also to confirm it. I may have written there f of n, it is un, everything is same. So un by vn, this is your g of n, or we say in general term v of n, right? Okay. It is like in integrals we use a function and this we use a terms. There's a difference, nothing else, okay? So basically you get root of 2n square minus 5n plus 1 upon 4n cube minus 7n square plus 2 into 1 upon n square. It will the 1 upon n square 1 upon n square, and this 1 upon n square will go upwards, so it will become into n square, and after that you can solve the limit. Okay, I'm not going to solve the limit, and you will check what value you get in the limit. Okay, and then accordingly you will say that this is convergent or divergent, but g of n, that is vn, is convergent, we know that. Okay, so now let's see another problem. If I will discuss every problem numerically, then it will take lots of time. Okay, so I'm just telling you all the concept which is required for every problem. Okay, so let's see another problem, and I hope you all are understanding it, right? It's not like that it's going everything blank. No, it should not be. You have come to learn, so you have to learn. Okay, that's the thing. Okay, so now let's see this question. This is the last question from sequence series, and then we will move on to some other topic, to maybe integrals, right? So you get x minus x square by 2 plus x cube by 3 minus x to the power 4 by 4, and so on and so forth. This is known as a alternating series, right? You all know this. I covered this, right? Solution. So we have to check whether is it converging or not. So what is the nth term in this case? It is equal to like un is equal to negative 1 to the power n minus 1 of the quantity x to the power n by n, right? You substitute 1, you get substitute 1, you get this. You put 2, yeah, that's okay. So by absolutely convergence test, we'll prove this thing. How? Let's see. So for absolutely convergence test, you have to check for this quantity, so on and so forth, right? So if this will be convergent, then this will be absolutely convergent, right? Okay. Else we can prove it conditionally also. But let's see for absolute convergence first of all, right? So what is the general term in this case? It is equal to u of n is equal to, let's say, u dash of this, so there's no confusion. Okay, it is equal to x to the power n by n, right? You got this very simple expression, right? So u of n is equal to x to the power n by n, right? This very simple expression which you have got. And now how do you evaluate it? Again, you see a power of n, which means you will apply Cauchy root theorem, Cauchy root test, I mean. Okay. So you get nth root of un of limit as n tends towards infinity of this quantity. You get limit as n tends towards infinity of x to the power n by n upon x to the power 1 by n, which we get limit as n tends towards infinity x by n to the power 1 by n. Again, you know this limit. This is x and this is n, right? So as n tends towards infinity, this limit is going towards 1. So we get x, right? So notice that this expression is convergent for like x less than 1, and for x greater than 1 this is divergent, and for x is it is convergent. So if x is less than 1, then this expression is, if x is less than 1, then this is absolutely convergent, and for x greater than 1 this may be convergent, this may be not convergent. If but we are sure for x less than 1 this is absolutely convergent, right? This is absolutely convergent. But for x greater than 1 we can't say anything, so we have to test for x less than 1. So we have to test this in a general way also, right? Let's see how. Okay. So notice that if x is for x greater than, so for x is greater than 1, let's see, x greater than 1, right? We are checking. Okay, greater than equal to, because in that case 1 is also not included, so I am including 1. Okay, so basically you get x minus the, what is the general term? It is again equal to negative 1 to the power n minus 1 x to the power n minus 1 by, sorry, n upon n, right? This is the thing. Okay, so what is the last term? We have to check now. Okay, so limit as n tends towards infinity x to the power n by n, right? This is the thing. You differentiate, you get x to the power n minus 1. This is the Leibniz test, right? You remember for Leibniz test, I'm writing LT, it's Leibniz test. Uh, this must be a decreasing sequence first of all, and second, that limit as n tends towards infinity, this expression must be equal to 0. So x to the power infinity, basically this is x to the power infinity, so this will be equal to 0 when x is less than 1 and greater than 0, obviously, because we obviously assume it is greater than 0. It means for x greater than 1 this is divergent, right? Greater than equal to 1, right? Okay, understood. Okay, so which means this is convergent only for this value of x, right? So with this we come to an end of the sequence series, and now let's come to integrals part, right? Okay. Sorry. Okay, so now let's come to the integral calculus. Integral calculus, right? Okay. So we are coming to now integral calculus, and in this we will solve like many problems based on the beta gamma function. And in this I'm not doing the problems for the convergence of integral, because I've already covered that in a separate one shot. So I'm not covering that because I don't think so. If the question comes from the sequence series convergence, then it will be asked in the integral one, right? That is why I'm skipping that part. You can watch that in my one shot of the integral calculus that I covered it deeply. It is like 1 hour lecture only. So let's start with the beta gamma function first of all in this. Okay, we will do one question first of all. So let's see the first question of integral calculus. Let's see the question, what it states. It states that we have to prove that beta of m comma n is equal to the integral 0 to infinity of the quantity t to the power m minus 1 by 1 plus t to the power m plus n dt, right? So how do we evaluate such kind of problem? Well, let's see. Maybe I can erase the upper stuff also so that I get more writing space. So let me erase this. Yeah. So now let's solve the problem. and let's see how we get. Okay, so beta of m comma n. Okay, so we will take this expression. This is 0 to infinity t to the power m minus 1 by 1 plus t to the power n plus n dt, right? You get this. Let me raise the everything written on the board so that now I have more space to write. And this problem looks like it is very difficult, but it is very easy. How? Well, you see 1 plus t, 1 plus something, which means you will start thinking about some trick function. And what is 1 plus t? You think that, yeah, if I put t square, then it will 1 plus t square, it becomes sec square theta, and it may work. Okay. So we will use t is equal to tan square theta, right? You may have used another function like cot also, but in that case maybe it would have been more easy. It don't matter. Okay, whatever be the case, you have to just use like tan or cot in this, since you have a plus sign. Okay, if if it would be like negative, then you would have used sine square or cos square, whatever. Okay, so dt is equal to 2 tan theta into sec square theta, right? You get this? Okay, so notice that when t is equal to 0, then theta is also equal to 0, and when t is equal to infinity, then theta is equal to pi by 2, right? So you get the limit 0 to pi by 2, halfway done, right? You get tan to the power 2 m minus 1 by 1 plus t square 1 plus tan square theta to the quantity m plus n into 2 tan theta square theta d theta, right? You get this thing. So you get 0 to pi by 2 of tan of 2m minus 2 theta by, what is this? This is sec square theta whole raised to power m plus n into 2 times tan theta into sec square theta d theta, right? You get this thing. Okay, right. Sorry. Okay, so now let's see if I can put somewhere duster. No, I can't. Okay, so this is the limit. This is the integral 0 to pi by 2 of the quantity. You can write tan in terms of like sine and cos theta. You remember tan theta is equal to sine theta by cos theta, right? You remember the simple thing, right? Okay, sine to the power 2m minus 2 theta by cos 2m minus 2 theta, right? And what is sec square theta? It is 1 upon cos square theta, so that cos will go upwards. So you get cos of 2m plus 2n, 2m plus 2n, right? I hope this is a question here. Into what we are getting over here is this, yeah. Into, yeah, this theta into 2 tan you can write again sine theta, 2 sine theta cos theta into this quantity. This is again 1 upon cos square theta d theta, right? You get this. Okay, as simple as that. Okay, okay, so let's evaluate it further. Let me raise that stuff also, else it will like confuse many times. Okay, so let me write it further. Okay, so it is 0 to pi by 2 of the quantity sine of 2m minus 1 sine theta, and this multiplier will add 1, so it will be 2m minus 1 theta cos 2m minus cos 2m plus this quantity upon this. What do you get? 2m plus 2n minus 2m plus 2, and this is minus 2 minus 1, this and this, like it will become cos cube theta, right? So basically it is minus 3. Okay, no need to be confused. And this is like cos, this is in the denominator, so it will be like subtracted from that power, right? I hope you are understanding it. 8 theta, right? Obviously 2 will be outside, so 2 times the integral 0 to pi by 2 sine 2m minus 1 theta. This will be like this theta, 2m and 2m cancel, and this becomes cos of 2n minus 1 theta d theta, right? And this is equal to beta of m comma n, right? You know the polar form of that beta and beta mn, right? It is this, right? That is what hence proved. Okay, it is as simple as that. It looked like it was very difficult, but it is very easy when you solve it, right? Okay. Okay, so now let's see another type of problem. Let's see what we get first of all. Okay, so you are given to prove like this question. This is very simple. 2 times the integral, this is equal to, you need to prove this stuff. E minus x square, x to the power 2n minus 1 dx. You need to prove this thing. Okay, how do we check it? It's very easy, right? It's like, let's see. So you put x square equal to t first of all. So you get dt is equal to 2x dx, right? Okay. So notice that integral 0 to infinity of e to the power negative x square x to the power 2n minus 1 dx. It can be written as the integral, and notice that the limit will be unaltered, because when x is equal to 0, then that is also equal to 0. Yeah. So this is 0 to infinity, and it is e to the power negative t. And what is x over here right now? So x is equal to, well, wait, we can write x as x to the power 2n minus 2 by into x, or x to the power n by x dx. We can write it like this, and we get dx is equal to dt by, yeah, we can write it like this, or yeah, x to the power 2n minus 1, we can write it like x to the power 2n minus 2 into x, we can write. Okay, so notice that there was a 2 over here, so you bring that, so you change it like this: 0 to infinity of e to the power negative x square x to the power 2n minus 2 into 2x dx, right? Now it is very easy to transpose, right? And you can write it like this: x square to the power n minus 1, right? Is it okay? Right. You put over here, you get t to the power n minus 1, since x square was t, right? That's why. And this 2x dx is dt, and this is equal to gamma of n. As simple as that, right? So simple problem. Okay. Okay, so now let's see another problem, and then we will start with some other topic. Yeah, we will do like 2 problems more in this gamma and beta function, then we will move to some other problems of like integral, multiple integral, right? So let's evaluate this thing, and then let's see. Okay. Okay, so let's do this question. Is it okay? Beta of m comma n is equal to beta of m plus comma n plus beta of m comma n plus 1. We need to prove this thing, right? Well, this is something new which you may have learned today, because I don't think so it was ever taught. So this is equal to, how do we prove this? So we'll start with the RHS term, okay? And it's very simple proof, right? Let's see. Beta of m, I should write it like this: beta of m plus 1 comma, I hope I should change the chalk, this is not working properly. So we get like beta of m plus 1 comma n is equal to integral 0 to 1 of x to the power m plus 1 minus 1 1 minus x to the power 1 minus x to the power n minus 1, right? So you get 0 to 1 x to the power m 1 minus x to the power n minus 1 dx, right? You will get this thing, okay? And now when you do beta of m comma n plus 1, you will get integral 0 to 1 x to the power m minus 1 1 minus x to the power n plus 1 minus 1 dx, right? And again you can write it like this directly, okay? Okay, so you just add these two things: beta of m plus 1 comma n plus beta of m comma n plus 1, right? You get integral 0 to 1 x to the power m 1 minus x to the power n minus 1 dx plus this quantity dx, right? You will get this thing, okay? Now let's see what we get after adding. Okay. Okay, you take integral outside 0 to 1, and this you make another function. You get x to the power m into 1 minus x to the power n minus 1 plus x to the power m minus 1 minus x to the power n dx, right? You get this stuff, right? Okay. You take x to the power m minus 1 and 1 minus x to the power n minus 1 as common, you get x plus 1 minus x dx. And to a great surprise, you get like x to the power m minus 1, 1 minus x to the power n minus 1 dx, and is equal to beta of m comma n. Hence proved, whatever was asked. Okay. You should remember this property. This is important, right? Okay. Obviously, I can't do all the problems in this video, so you have to watch my other one shots also. Like there are 3-4 one shots available for end sem, so you can watch them because in that I put like many questions. I can't cover every question in this right now. Okay, so there's a property which I need to tell you all, that gamma of n into gamma of 1 minus n is equal to pi sine of n, right? Like you should remember this property, it's helpful in many cases, right? Okay, so now let's see a question. Yeah, this question is really important, right? You should like know this. It is really important in my opinion, because I hope so there can be a question related to it. Sorry. Integral 0 to 1 of t to the power m 1 minus t to the power n to the power p dt. Obviously I covered this in my one shot because at that time also I said it is very important, so that is why I am covering it again, else I should have not covered this. Okay, so you have to use t to the power n as equal to x, right? Basic idea. So you get over here that dx is equal to ntn minus 1 dt, right? You get this? No, you get x is equal to t to the power 1 by, sorry, t is equal to x to the power 1 by n, right? This is the case. Okay, and t is equal to, yeah, so dt is equal to 1 upon n x to the power 1 by n minus 1. Okay, is it okay? Yeah. So t to the power m is equal to, like, you raise both sides, x to the power m by n, right? So notice that when t is equal to 0, x is equal to 0. When t is equal to 1, then x is also equal to 1, right? 0 to 1, x to the power m by n of the quantity 1 minus, what is t to the power n? It is again x to the power p of the quantity dt 1 by n, this is dx also, 1 by n into x to this x, right? My x and n look like similar, I'm sorry for that. 1 by n minus 1 dx, right? I have to be careful right now. Okay, I have to be careful. So it is 0 to 1, you can take 1 by n as common. So you get x to the power m by n, you add this and this, you get plus 1 by n minus 1, 1 minus x to the power p plus 1 minus 1. You know why I have did this, because it is of the form n minus 1, so that is why I have to make in that form. We are told to write this in terms of beta function, so that is why. Okay, so 1 by n integral 0 to 1 of the quantity x to the power m plus 1 by n minus 1, 1 minus x to the power p plus 1 minus 1 and dx. You get the answer as 1 by n into beta of m plus 1 by n comma p plus 1. It is like really important result. You should remember this result even and the proof even, because there are multiple, like they will ask you a question like 0 to 1 t to the power 9 into 1 minus cube to the power like suppose 10 dt, right? There are some problems like this, or maybe they might ask 1 minus root, whatever, like they can change the values m n and p, they can permutate or combinate that, and they will like give you such questions, right? Okay, so that is why you should remember this thing, that is why I discussed it again. Okay, okay, so let me write another question and then we'll solve it. Okay, okay, so now let's see another problem. It's I guess around 40 or 50 minutes lecture already. I have to complete it like in some less time. Let's see question. So gamma of n plus 1 by 2 is equal to root pi by 2 to the power 2n minus 1 gamma of 2n by gamma of n. We need to prove it. So how do we prove it? Let's see. Okay. Yeah, and the proof that gamma is of 1 by 2 is equal to root pi is really important, right? I won't discuss it right now because we don't have time. So that is why you should watch my integral calculus video. In that I have covered this also, and there are many other questions which I have covered. So you should watch that lecture first of all, then you should come to this lecture. Okay? Right. Okay. So gamma of n plus 1 by 2, you can write it from the property that gamma of this is the property. Just apply it. N plus 1 by 2 minus 1 into gamma of n plus 1 by 2 minus 1, right? This is the thing. So you get n minus 1 by 2 into gamma of n minus 1 by 2. And you again apply this property, you get n minus 1 by 2 into n minus 3 by 2 into gamma of n minus 5 by 2, right? You'll get like this n minus 3 by 2, right? Is it okay? Is it clear? Yeah. And you will go till gamma of 1 by 2, right? Okay. Let's see. So let's see what we get. Sorry. So you get gamma of n plus 1 by 2 is equal to like n minus 1 by 2 into n minus 3 by 2 and so on and so forth till gamma of 1 by 2 till here 1, right? Okay. So you get 2n minus 1 into 2n minus 3 so on and so forth till 3 into 1 into gamma of 1 by 2 and by 2 by 2 by 2 by 2, right? You'll get this thing, okay? This 1 by 2, right? Okay. So let's see. And notice that they are like n terms over here because 2n minus 1 is equal to 1, right? 1 plus n minus 1, what is the common difference? 2, you will bring it over here, so 2n minus 2 is equal to n minus 1. So this is the, suppose the k term, k minus 1 is so 2, so you get k is equal to n, which means there are n terms. So there will be n power, or there will be n power of 2 in the denominator, right? Okay, so let's see. Okay, so let's see this thing. You get 2n minus 1, 2n minus 3, so on and so forth till 3 into 1. 3 into 1 into gamma of 1 by 2, you know it is root pi, but I am not substituting right now, okay? For some reason. 2 raised to power n, right? You get this thing. Now what you do is, you will write it like this. 2n minus 1 into 2n minus 2 into 2n minus 3 into 2n minus 4 and so on and so forth till 3 into 2 into 1 into gamma of 1 by 2 upon 2 raised to power n into 2n minus 2. Obviously you multiplied by that, so you have to divide by that to make it equal to 1, okay? 2n minus 4, 2n minus 6, so on and so forth till 4 into 2 into this quantity. Now you take 2 common from each expression in this, okay? So this is equal to 2n minus 1 factorial by 2n into 2 into 2 into 2 and so on and so forth till n minus 1, n minus 2 and so on till 3 into 2 into 1 into gamma of 1 by 2, right? Is it okay? I taken out 2 from this. I took common 2. I took 2 from this, 2 from this, and 2 from this. Right? Okay. That is why it become n minus 1, n minus 2, n minus 3, n minus 4, and so on and so forth, and so on and so on. And you got 3 to 2 into 1, right? Okay. So sorry, I'm really tired, so that's why my words are like fluctuating. So that's why don't worry about that. I will try to keep the same energy throughout the lecture. So this is equal to gamma of 2n, right? And this is equal to 2 raised to power n into 2 raised to power 2n minus 1. This is n minus 1 factorial into gamma of 1 by 2, right? You got this thing? Okay. Let's see it further. Okay. So you get gamma of 2n by 2 raised to the power 2n minus 1. How? 2 raised to the power 2n into 2 raised to the power 2n 2 raised to the power n minus 1, which is equal to 2 raised to the power n plus n minus 1, which is equal to 2 raised to the power 2n minus 1. Right? You got this? Is it correct? Yeah. So you get 2n minus 1 into n minus 1 factor, it is equal to gamma of n, and it is equal to root pi by root pi. That gamma of 1 by 2 is equal to root pi. Those who don't know, kindly visit my video of integral calculus. In that I have covered like that one shot. I have covered like many uh, questions and all the concept related to integral calculus which is required. So okay, let's move on to the next question right now. Okay, let's see another problem. Yeah, it's done. For integral calculus, it's done. Like these are some important questions, and if I'm not covering like improper that convergence one, because I've already covered in the integral calculus part, so you can visit that. Okay, these are really important, so that is why I had to discuss it again. Okay. Now let's see some concept, some questions on multiple integral, multiple integrals, right? So let's see how we approach multiple integrals. First of all, you should know that how we assume the polar coordinates in that. Suppose you are given this region, suppose W, some region, f of x comma y comma z, dx, dy, dz. Okay. So first of all, I will start with the spherical region. Why do we assume? Like we assume x is equal to r sine theta cos sine phi. Then we assume y is equal to r sine theta into cos phi, and then we assume right it's sine phi and cos theta, right? And z is equal to r cos phi. Why we do like this? In this case, you get Jacobian xyz is equal to upon r theta and phi. You get r square sine phi, right? Okay, remember this. Okay. So what's the need of all this? And this in this we say that r is greater than 0 and theta belongs to like 0 to 2 pi, pi belongs to like 0 to pi. Why this case? Well, let's try to understand it. This was your like original coordinate system x, y, z. We are not worried about this. We are worried about this thing. So how do we approach it? Let's see. R square sine phi, right? Now I need this much space. You write this, you write it like this, and you make like x-axis over here. You make a z-axis, whatever axis you want to say. This is your r, this is your phi, this is your theta, right? So basically you are going like this. This is your semicircle, right? This is your semicircle, right? And this is your like this is your radius r, this is your 0. So that is why when you integrate it, so this is somewhat like this. If I can show you, yeah, this. Suppose this is a plane, this is this paper. So this is your. If I'm not having anything right now to show, but you will take it is somewhat like this. Okay, you will rotate it like this, counterclockwise or maybe clockwise, whatever. So in this case also you will take the semicircle, you will like rotate it 2 pi 360 degree. So that is why the theta will be like theta will range from 2 pi, right? And see the phi is from like it is 180 degrees. So that is a phi is lying between 0 to pi, right? And r is like 0 to r. Okay, so this we integrated from 0 to here, right. So we are concerned about the volume of this sphere right now. Okay, so that is why we put limits like this. Okay, and notice that if it is asked like for in the first quadrant we have to calculate, so in that case we will erase this stuff and it will be left like this. Okay, so in this case for one quadrant we will go like from here to here. So here r will be greater than 0 and phi will lie from 0 to pi by 2 since we only covered first quadrant. Okay, and theta will also be 0 to pi by 2, right? This is how you assume the limits. Okay, obviously opposite, right? This is for the first quadrant and that was for the complete sphere, right? So that is why that is how you assume the things, right? Okay, now coming to the cylindrical part. Okay, cylindrical coordinate system. Let's see how we assume it, and then we'll see some problems, and then we'll end the lecture because I'm really tired also, and like we have covered everything almost, right? That is why, and I hope so that please you will subscribe the channel at least, okay, and please support my channel. So now let's see the questions. Cylindrical, basically cylindrical coordinates. Let's see. So this is the integral again. Suppose D is the region, f of x, y, z, dx, dy, dz. You get this thing, right? Okay. And now what we are going to do is that we have to assume the cylindrical coordinate system. So in that, how we will use x is equal to r cos theta, y is equal to r sin theta, and z is equal to z. Why are we doing like this? This is the basic question. Well, suppose you this is your sheet, this is your z axis, okay? You take x and y plane. Suppose this is your let me try to draw it. This is your y, x, and this is your z which is coming out, okay? So you basically taking a sheet, suppose this, and you are trying to revolve it, rotate it like this around a length of z. So that is why we haven't changed the value of z. And notice you are getting a circle. So that is why you converted it to the polar of circles, right? That is why x is equal to r cos theta, y is equal to r sin theta, and z is equal to z. And in this case, the limit also you will take like 0 to 2 pi, right? And r will be greater than 0, right? That's the thing. Okay? It is going across this whole plane. Okay, that's why. So now let's see some problems, and then we will end this lecture. Okay. Sorry. I'm really sorry, my words are fluctuating a lot, so kindly bear with it. Okay. Okay, thanks. Okay, so now let's see a question. So I won't solve the complete question, I will just tell the method and you all will solve it. Suppose I covered this in my like previous lecture also. Integral this e to the power x, e to the power x plus y plus z, dx, dy, dz in the box region 0 to 1 cross 0 to 1 cross 0 to 2, right? 0 to 1, sorry. So how you will do this? This is your x limit, this is your y limit, this is your z limit, and they all are independent. So you get 0 to 1, 0 to 1, 0 to 1, e to the power x plus y plus z, dx, dy, dz, right? That is how you will integrate it, right? I am not solving further because I covered in my integral calculus lecture. You all can visit that channel, okay? That video, sorry. Channel is only one, that Philosopher's Academy. Okay, this is the thing, okay? You can evaluate it, you will get the answer as e minus 1 to the power whole cube, right? I covered in that lecture, so I can't waste time on that, okay? Okay. It's like have been a very hectic schedule for me also because I was like covering all this like I made everything in like 3 4 days only. Like I used to take daily lectures, so that is why. And it takes like lots of time to prepare for one lecture because I have to teach like that. If even the one who does not know anything, they should also learn something. I try to make like that. That is why. So let's see another type of problem. Let's see this one. 0 to 1, 0 to x square plus y square to 2 of dz, dy, dx, right? So we are having this thing. So we are having this thing, and now let's say evaluate 0 to 1, 0 to x, and this dz, this is the limit of z since it is the limit is dependent upon x and y, so that is why it will be the limit of z only, okay? So we get z limit as it goes from x square plus y square till 2 of the quantity dy dx, right? So you again get 0 to x, 0 to sorry 0 to x, right? This is again the limit of y since it is over here we see x, right? You have to watch my integral calculus lecture for that to know how we are doing this. This is 2 minus x square minus y square. It is very simple, okay? Dy dz dx. You have to watch integral calculus first of all, else this will go like a bouncer to you. That is why. I hope you all are understanding now. So that is why. I guess my lecture is not getting bored. I guess my lecture is not boring. I hope so. So please try to learn as much as you can. And yeah, really, I'm really tired and I'm not well. So that is why my words are like fluctuating like anything. So please kindly ignore this thing. Okay. Okay. So now let's see. 0 to 1, and you evaluate this, you will get 2y minus x square y minus y cube by 3. You substitute 0 to x dx, right? 0 to 1, you substitute 0 over here, you get 0 everything, you substitute x. Obviously, you will substitute x in the place of y only, you won't substitute x in place of x square, it is useless, okay? So limit. So just remember that whenever you're substituting the value of the limits, you have to remember that in what reference you were integrating it. Like you were integrating with respect to y, so you have to put the value of the limits in y only, not in the place of any other variable, right? So 2x minus x square and x cube, since it is x, yeah, minus x cube by 3 dx. 0 to 1 integral, you can evaluate it 2x minus 4x cube by 3 dx. You get x square minus x to the power 4, 0 to 1, and this is equal to 0. Sorry, by 3. 1 minus 1 by 3, this is equal to 2 by 3. I hope the answer is correct or not, I don't know, but this is the method, okay? Right. Okay. So we have now, the question is to find the volume of a sphere of radius equal to r. Right? This is the, I guess this is the question. Find the volume of the ball or the sphere of radius r, and in the region x square plus y square plus z square less than equal to r, of course, right? So we write volume as equal to x y z, right? Length into breadth into height. So that is why, that is how you write in the terms of integral. You write integral dz dy dz, right? Like this, okay? Since it's a sphere, we can use spherical coordinate system. It is very easy to that. So notice that if we use the spherical coordinate system, it will be like dr, this will be d phi, this will be d, or wait, d upon a region, d upon a region, dz dy dx. You get this thing, okay? Now it will be 1 over here because we are just calculating x y z, dx dz dy dx. That is the thing, okay? Sorry. So now when you convert it, like you will convert x is equal to r sine phi into cos into sine theta, and y is equal to r sine phi into cos theta, and z is equal to r sine r cos phi, right? You will convert this, and when you will solve, you get that now. What was Jacobian? It was r square sine phi, right? R square sine phi times d phi d theta. Limits are from 0 to capital R. Phi is going from 0 to pi, since we are calculating the complete volume of the sphere. And for d theta, it will go from 0 to 2 pi, right? This thing. And suppose if you are asked like to find only the quarter, then it will go from 0 to pi by 2 and 0 to pi by 2. All this, okay? I explained that earlier. Okay, you should watch that from beginning then, if you could not understand. Okay, so now let's see how we evaluate it. Okay, so now let's see this integral 0 to 2 pi d theta. Since d theta, there is no term of theta in this, so we can break this integral like this into this integral and this integral separately. 0 to pi sine phi d phi integral 0 to r square dr. You know that if the function are like this, some region f of x y z dx dy dz, is equal to integral like fy fz dz, and the limits are supposed defined a to b, b to c to d, e to f, and they're like independent limits, like they're not dependent upon any variable. E to f, d to c to d, a to b. You can break it like this: integral a to b fx d dx, right? Fx dx, since it will be fz dz multiplied by c to d fy dy and so on, right? That and the function. Okay, I'm not writing that, but I covered that in integral calculus class. You can please visit there. Okay, I can't tell everything right now. Okay, this is the thing. So basically this is equal to pi. This is equal to like negative of negative cos phi. Negative cos phi limit goes from 0 to pi. Let me write it. Negative cos phi limit goes from 0 to pi, 0 to r, and this is r square, r cube by 3, and it goes from 0 to r, right? And you can change the limit 0 to this, right? You get this thing, okay? You get this. So you get 2 pi times cos of 0 minus cos of pi into r cube by 3. You get 4 pi r cube by 3. That's it. This is the volume of a sphere, right? You all know it. Okay. Okay, so let's see if we have another question. We will solve two more and then we will end the lecture. Finally. I hope you all learned a lot from this video. If you learned anything new, then please do like, share, and subscribe my channel. And really, lots of thanks to you for watching my video also. Okay, so now let's see this question. We are given x square plus this triple integral dx dy dz x square plus y square plus z square 3 by 2, right? We are given this, and the region is given that we have to find the derivative. X square plus y square plus z square equal to a square, x square plus y square plus z square is less than equal to b square, and you have to find like what is the question? Yeah, you have to find this. You have to evaluate this integral, and you are given a is greater than b. Okay. So again, you will use the spherical coordinate system in this, so it will become really easy for you to evaluate it. Let's see. So you get this will be 1 upon r square to the power 3 by 2. I'm not showing how I converted, I already showed it. Okay, so please don't ask me to write that. R square into sine of phi dr d phi d theta. Notice that the theta goes from 0 to 2 pi, phi is going from 0 to pi, and r goes from like b to a, right? Okay. Again, evaluate this integral, you will get like 4 pi by 3 times ln a by, okay, so it will like I just wrote this. Okay, 0 to 2 pi d theta, 0 to pi sin phi d phi integral 0 a to b, b to a, sorry, b to a of the quantity 1 upon r dr. You get 2 pi into this 2 pi into 2 into ln r b to a. You get 4 pi, you get 4 pi, right? 4 pi ln of a by b, right? So all you get this. Okay, I hope that the calculation is right. Even if it is wrong, it don't matter, because I wanted to tell the concept first of all, right? That's the thing. Okay, if there is any problem, you can comment me in the comment section that I made a mistake over there. I will try to see that thing. Okay, maybe I am right now very much tired, so that is why there are chances that I can make mistakes. That is why. Okay, and bear with it. Okay, so now let's see another problem. Well, if we have any, let me check. Well, yeah, this is the last question. No, this is like, yeah, this is the last question. You have to find the volume of tetrahedron in the region x equal to y equal to 0, and z is equal to 0, and x plus y plus z is equal to 1. Right? Is it okay? So basically you will do this integral this dz dy dx. You will draw a region, you will draw a tetrahedron, and then that you will show. Like let me tell you all. This is your x x y z. This is your 1 comma 0 comma 0. This is your 0 comma 0 comma 1. This is how the region looks. So you are consider the area, the volume of this thing, right? That is why. That is the thing. So it goes from like 1 0 to 1 minus x minus y. Then you substitute y as 0. You get it goes from 0 to 1 minus x, and then it goes from 0 to 1. You evaluate this, you will get the answer, right? Whatever you get. Okay. This is how you solve such kind of problems. Okay. So I hope you all understood everything what I taught, and if there's any issue, you all can comment. You all can comment in the comment section, right? Or you can message me directly, okay, on Telegram or WhatsApp, whatever. Okay, and please do like and subscribe my channel. And yeah, there are many questions which I could not cover in this one shot. For that, you have to watch my lectures so that everything becomes clear. Like the change of order I could not cover in this because of the lack of time. So that is why you can watch it from the integral calculus video. In that I have explained it clearly. Okay. So I hope I hope that you all learned something new from what I told today. So I hope that you like the video. Please do like, share, subscribe my channel. And thanks a lot for watching it. Bye bye. Take care.